Welcome everyone, and thanks for joining us today. I'm Joe Sagona, I'm the head of business development over here in the US for MGM Technology Partners. And for the next 30 to 45 minutes, we're going to be talking about MGM's approach to risk-based testing of software. So first, a little housekeeping. Should, as I said, take about 30 to 45 minutes to get through this. It is already being recorded here. Feel free to ask any questions that you have into the chat, and we'll get to those at the end. And first up, a little bit about MGM. We're an international software company with an integrated service portfolio. We have 19 locations worldwide across 7 different countries with about 1,000 employees across those locations. We offer consulting, custom development, as well as several SaaS offerings to ensure that we can provide a complete package to our customers. We spread those out across our consulting partners, integration partners, security partners, and our quality partners. And today in particular, we're going to be talking to you about one of our specific SaaS offerings, Q12-TMT. It's our homegrown test management tool that we use in all of our projects across the different verticals. And in the agenda we have today, what makes us professionals at risk-based testing, our scientific approach to risk-based testing, and a little demo from Richard and to show you how we use the risk-based testing in our day-to-day here at MGM. And last, we'll have a little Q&A where you get to grill these guys and ask all of your questions, and anything that we can't answer, we'll get back to you afterwards via email. So without further ado, here's some of the interesting stuff coming up. These guys will introduce themselves. So Richard, Oliver, feel free to take it away.
All right. Thanks for the introduction, and welcome also from my side to our webinar series on test management. Today, we are focusing on risk-based testing. My name is Oliver. I have been with MGM for 16 years now as a project manager, and I was constantly engaged with software development and QA, so that's my background. And for the past 3 years, I have been the responsible product manager for the development of our test management tool, Q12-TMT. And with me today, we have Richard, who will introduce himself in a minute. But before we dive into that and into the webinar, I would like to explain you what gives us the expertise to talk about test management and about risk-based testing. So we, as a company, we develop and test software across various industries, and one of the focus areas is the public sector, where an important project is for the German tax authorities, like a My Tax application, which all the German citizens use to submit their annual tax returns. And this project alone involves about 100 testers. And if you add up all the other industries that we serve, we have about 250 testers at MGM. So that means we have an extensive and also a very diverse QA expertise in-house. And well, we mainly deal with mid-size to large-scale settings. So this led us to deal extensively also with project risks. And to tackle that, we introduced risk-based testing like about 10 years ago already. And about 3 years ago, we integrated that into our test management tool as a key feature. And that is now an offering on the market as well. To see how that works in theory and practice, my colleague Richard will now introduce himself and then take over for the explanation.
Yes, thank you, Oliver. Thank you, Joe. My name is Richard. I started at MGM 4 years ago, almost to the day. So right in the middle of the pandemic, if you remember. Yeah, I started out as a software tester, but since 1 year, I took over also the business analysis part for our own test management tool, and we had a special focus on risk-based testing. And this is what we're going to talk about in the next 30 minutes. Yeah, risk-based testing. Let's start with a little bit of scientific background. As Oliver said, we do risk-based testing for almost 10 years. It started out in 2015 with our esteemed colleague, Dr. Martin Farndorf, who wrote a scientific paper together with some colleagues from the University of Innsbruck. This paper was about a Bayesian prediction model for risk-based test selection. They conducted a study for a rather complex software system that had frequent new releases with multiple snapshots and multiple testing phases. And they also had a good knowledge about the past defects, so they could estimate the probability of a defect occurring in one space of the application, and could also estimate the cost that comes attached with fixing such a defect. So let's take a look at the model that they created and how it performed. Here we can see an operating characteristics diagram where the detection rate is plotted against the false alarm rate of this model. What you have to know about these kinds of diagrams is the more this curve is oriented into the upper left corner, the better the model is. So if it were just a straight line like here, it would make random assumptions about is a test worth selecting for a test run or not. And if it was oriented in the other side, so to the bottom right corner, it would make especially false assumptions. So it would suggest to you to take all the wrong test cases. But we can see it did indeed do perform very well. So it, yeah, the selection it made was very good. And we took, or if we take a look at this paper and the math behind, we can take two different stances here. One is, if you have an unknown budget, you can calculate two different risks. First of all, the risk of not executing a test case, and then the risk of executing a test case. And by subtracting one from the other, you can calculate this delta R value. And in the end, for every test case, you can order them in the order of these delta R values and execute these test cases in order so that when you run out of budget, you can be sure that you covered all the riskiest parts of the application. But if you know your budget and even more parameters, you can calculate this base risk parameter for every test case, where you multiply the cost ratio and the probability ratio of a defect occurring. And afterwards, you can execute all the test cases which have a base risk parameter value which exceeds a certain threshold, which is tied to the budget that you have at hand. This is just a small part about the math that I'm showing right now. There is a lot involved actually with likelihood functions and simplifications of complex other functions. But this made us think how we can take a look at risk-based testing, how we can enhance it even further and what we came up with was this so-called lasagna principle, where we evaluate risks on different layers or perspectives. And these perspectives are the business logic, the test history, the release scope, the tester allocation, and the code changes. And all of these layers do interact with each other. And if you take all of them and aggregate them, you can derive such a risk heat map so that you can identify the risky hotspots of your application and therefore derive the priority of test cases and plan accordingly. And it is called the lasagna principle because this resembles a lasagna with different layers, which all individually have their value, but only if you combine all of them or multiple together, you will have a delicious lasagna that can be enjoyed and is even better than all of the single parts. So now I'm going to take a look at every specific layer, and we will start with the business logic. If you are working in software testing, you are probably familiar with this, at least if you heard about risk-based testing. This is like the classical approach to risk-based testing, where you can manually define the likelihood and the impact of a defense occurrence for a test case at hand. We also do this here in this layer, where we can select one of 5 different settings for each of these parameters, which leads to a 5x5 matrix that we can cluster into 3 different parts. So we have a part that is about low risk test cases, we have a part for medium risk test cases, and one for high risk test cases, depending on the parameter combination. But what we also do is we want to provide tool support, so that you don't have to do it manually by yourself, but that the tool is suggesting some settings for you so that you can focus on other more important parts and not constantly evaluate the risk for single test cases. Yes, the next layer is the one of test history, where we take a look at the past executions of test cases. On the one way, we want to calculate, or we calculate a failure ratio for every test case. So then we take the amount of failed executions of a test case versus the total amount of executions, and that leads to a percentage between 0 and 100%, and that we can use to assign one of 5 settings as well, depending on this percentage. On the other hand, we calculate also the average severity of a defect that is tied to such a test case. So when a defect occurs, you can prioritize it in your issue tracking system like Jira or Azure DevOps, and this priority says something about the severance of such a defect. Like if it's a blocker defect that you cannot access your web shop anymore or something like that, versus a minor defect that is only about some small UI issue or a spelling mistake. Then we apply weighting to all these different priorities. We take the average out of this, and then we can cluster this as well into 5 different settings, which leads again to a 5x5 matrix, where we can derive the risk setting similarly to what I explained in the business logic. The next layer is the one of the release scope, where we want to focus on test cases that are particularly interesting due to the release that you have at hand for your software. First and foremost, there are new features that are going to be introduced with almost every release. So therefore, you create new test cases, or you adapt previous test cases to the adapted features. And what we do, and I'm sure most of you do as well, is establish a link between those test cases and the respective tickets that you link as your sources, for instance, requirement tickets or story tickets. And given this link, this connection, we can then find out which test cases are affected, and they are given a high risk most often because we again rate it depending on the priority of the respective requirement or story tickets. Another important part of each release is defect retesting. So if there were bugs occurring in previous releases or during the development phase, they are fixed in a release, and therefore you have to do defect retests to make sure that those defects indeed do not occur anymore. And we link also those defects to the past executions of test cases, and this connection allows us to again identify the test cases that are relevant for retesting such defects, and we assign this medium risk. Again, there is a small margin depending on the priority of the defect. And both of these test types also are relevant for regression testing to make sure that the other parts of the application, or at least the ones that are close to the features and the bugs that occurred, are properly retested and still work as they should. And therefore, we use tags. So keywords that are assigned to test cases, like if you have a test case for paying per credit card in a web shop or paying per PayPal or something like that, then they are given the tag payment, for instance, and all other test cases that have this tag payment are then featured as regression tests, also with a medium risk, not as high as the new features. And again, it's a little bit depending on the priority of the ticket that was used as the requirement, story, or defect in the first place. Every test case that is not linked to such a ticket in the first or in the second place is be considered a low-risk test case and is not really worth the effort of testing out of this scope. The fourth layer is the one of tester allocation. And when I say tester, I also mean like test automation engineer, anyone who is involved in creating and executing test cases, because that comes with some risks attached. First, there is the problem of availability. Maybe the tester who is responsible for a test case works in many projects and therefore is only part-time available for your project at hand, or they are on paternal leave or they have vacation planned in the next weeks. So all of this plays a role in estimating the risk that comes with this. Also, there's the fact that some testers have a huge know-how for the specific problem for your project, or work in the field for 20 years or even more. But there are also people who start out new, like everybody from us has done in the past. And you have test case time constraints. With MGM, we have some test cases that have to be executed during a whole weekend and constantly monitored, or over the course of 2 weeks. And this plays a role as well, because you can't repeat them as much as you want if there is something occurring on the environment, for instance, or something like that. And taking all of these together, we can derive a risk for test cases, for instance, which have a high execution time and are assigned to unexperienced testers. You would give them a high risk rating, whereas if you have a test case with a short execution time and highly experienced testers assigned, this is considered more a low-risk test case. And the last layer that I want to talk about is the one of code changes. If you're a tester, you probably know, or you had the problem that not everything that is that was changed in the code is documented in your requirement or story tickets. There are probably some hidden changes in the background, like the development did refactoring, or a library was updated. And of course, this is not obvious to you just reading the requirements. And by establishing a connection between the code that is used for a test case execution and the test case itself, we can derive a risk evaluation. So a test case that deals with newly written code is considered a high-risk test case. A test case that deals with changed code, this was slightly adapted, is more a medium-risk test case. And a test case where the code that is linked to it isn't touched at all would be a low-risk test case. So what do we do with all of these layers coming together? We derive a heat map. And what we can do with this, I want to shortly demonstrate in the system itself. So let's jump into the system. There it is. So this is Q12-TMT, our own test management tool. I'm here in an example project created for this webinar. It's a classic web shop. And I'm on the page for risk-based testing. Here we can see the selection of the different layers. I'm currently in the heat map layer. I can also select one of the singular layers, like for the business logic, and the pie chart tells me how the risks are spread across the project. But right now I want to focus on the heat map. So these segments that you see here from the pie chart each represent a test suite of the project. Like here, this test suite is for order management. And the size of a test suite is represented by the size of the respective segment. So yeah, this test suite here has more test cases like this test suite here. And you can also see the colors, which symbolize the risk distribution in such a test suite. This test suite here is almost only in yellow and orange, so it has mostly medium risks. And in this test suite here, we have red as well as yellow and green, so all different risk levels, and also a huge share of undefined risks in gray, where not enough data is available to do a proper risk evaluation. And I can now, for instance, say, okay, show me all the test cases with a high risk. There I can see all those test cases that have a high risk, and they are aggregated based on the risk that is given on the singular layers. The logic here that we have is that if one layer has a high risk, the test case is going to be classified as overall high risk as well. And depending on the other layers, which have like a low risk or an undefined risk, the color changes will go back here as well. So therefore we have different levels of high risk that you can also see by the different red or different green or yellow colors here. So yeah, what can I do with this? I can say just create me a run, please. So I want to cover all of these high risk test cases in the next test run that I'm going to execute. Then I can click here, and a new background job is initiated. And in just some seconds, the test run will be finished. It is indeed. We can jump directly to it. Here it is. We can see based on the title of the test run that it is based on the risk-based testing, and we are covering overall high-risk test cases here. I can go into the test scope to perform the testing, and I can say I want to, for instance, order my test cases based on the business logic. This is the first and foremost and the most important parameter for me for testing, so that I cover the most risky business logic test cases first. Then I can go from top to bottom, perform and execute the test cases, and can be sure that I covered the high-risk business logic test cases first. But what if I'm not that satisfied with the test run composition? If I want to do some further adjustments, I can go to the test selection and use the Smart Select feature. There you can select multiple criteria and settings. Right now, we're going to focus on risk-based testing only. Let's say for the release scope, if they have the testing type, no test type, so there are no feature test, defect retest, and so on, I want to exclude those test cases. I don't need any of this. I can then deselect the matches, and I can see one test case was deselected. I can also do the opposite. And for instance, I say the test history is also especially important to me. Please include all, what can I say? All test cases that have a failure frequency of almost always. So they almost always failed in the past. I want to include them as well. Then I select those test cases, and one more test case was selected. I could go even on and on, but I think that's enough for a short sneak peek, and I want to go back to the presentation where I want to talk a little bit about new concepts that we developed. And I was told that these can be a bit nerdy. So if this is your thing, then lucky for you. The first concept is another concept of risk aggregation and quantification. I just told you that we have right now the aggregation logic of if something is high risk in one layer, then it is also an overall high risk test case. But we are not really satisfied with this approach. We saw that it is not really fitting our needs, and therefore we came up with the system of allocating Fibonacci numbers to the specific risk parameter combinations. The Fibonacci numbers are occurring almost everywhere in nature. It's a really cool phenomenon, and also it's part of software testing. If you're dealing with story points to evaluate complexity or something like that, you might be familiar with this as well. And what we did, we assigned a different Fibonacci numbers to the risk clusters to make them more granular based on their number of places. So all Fibonacci numbers with one place are assigned to low risks, with 2 places for medium risk, and if they have 3 places to high risk test cases, so that it's obvious at first glance which risk cluster such a test case is in. And then we can aggregate it as an inherently weighted average, because something that has like 377 risk points, so to say, contributes more to the risk rating than something like 5 points. And therefore, we also have a quantifiable metric and can do something like sophisticated risk reportings and stuff like that. And the other thing is automatic risk evaluation. I already spoke about this a little bit in the business logic layer. I want to elaborate it a bit more, how we did perform this automatic risk evaluation. Therefore, we can define a number of keywords for a project. And every test case that has such a keyword or multiple keywords are given a specific rating that is allocated to this keyword. And also we rate the test case complexity based on the amount of test steps that is necessary to conduct the test, or the length of the preconditions, how many things you have to set up first. And both of these combined can also lead to an automatic risk evaluation, which is also updated as the test case itself evolves, as well as the project as a whole, which have to be taken into account. And this is something to support you in your decision making. You can still say, I don't trust this system. I want to assign those risk values by myself. But you can also use it as a guideline. Or if you don't want to do it for 100 test cases at once, you can just take the system and have it done in just a few seconds. All right, that's it from my part for the risk-based testing. I now hand over back to Oliver to explain a little more of what is Q12-TMT.
Thank you, Richard. So we have now seen what is possible with risk-based testing and how we apply it, how we have translated the theory into practice in our test management tool. But now, how does this fit into the bigger picture? So first, a quick word about Q12. Q12 is the name of our quality landscape, which consists of the TMT in the middle. So Q12-TMT, you can see the tile, but we have more tiles. That means we have other tools, because we also cover test automation, test data generation. So for each of those disciplines, we have different tools, and they can be connected to each other with the API that the tools offer, and that helps to cover the different disciplines and to make use of multiple tools. Of course, you can also use third-party tools, so you're not bound to the MGM solutions. For example, if you prefer doing the test automation with Playwright, then do it and connect Playwright to TMT, for example. But now back to TMT. In some customer projects, on the next slide, we can see we also use tools from other vendors. So we do not use TMT in all projects, almost all, but not all. But that puts us into a good position to compare the vendors or the tools from the other vendors with our tool as well, which we do continuously. And there are many ticks and checkboxes here, so ignore the details. I just would like to highlight one of the things. This is about the first 3 lines, which deal with risk-based testing. So all providers, they allow some sort of risk management. And you can set up or implement a risk management process with them, but you have to do it yourself and you have to implement it yourself, and you also have to stay very disciplined when repeating the risk assessment with every new release or new test cycle. So this is the one thing. And the other thing is that the multi-layer approach that we have been presented by Richard just minutes ago, none of the others has that. So it is mostly focused on one layer and mostly the business logic, but they do not incorporate like test history or release scope and all the other layers that we saw. So yeah, if you're interested in the comparison or maybe today's slides at all, then just send us a message on LinkedIn or an email and we could share the details with you. But yeah, now next, let's have a look on what we are working also regarding risk management. Our focus is about risk management and clear visual representation of risks. So not only classic lists and tables or pie charts, but a more innovative way. And what you can see here is a first attempt how to display a heat map in a traditional style. However, when we mapped the existing data by the functional order and business logic hierarchy, then the result was a bit a scattered risk distribution. Because the project has many test cases, this feels like the risk is very distributed between the test cases. So every single dot you can see here is a test case of a project. Therefore, we sorted the test cases by risk values. And now we have some sort of like a thermal image that shows the risk status of your project and the test cases in a sorted order. And you can see, well, there's quite a balance between high risk, medium risk, and low risk. Better would be to have more green color and at least less red color or dark red color. So this is to find out how is your risk status in the overall project. And then another experiment that we made is about grouping risks by test cases. By test suites. So again, each dot is a test case, and we arrange the test cases by test suites. So every of the spots here is a test suite with test cases, and then within the test suites, we sorted the risk from inner to outer layer. And when we had this view, it looked to us like a bacterial colonies on a Petri dish. So each colony is representing a test cases, and we could visualize the infection of risks in your project and in the test suites. And on the next slide, we see another feature that is planned for implementation in the next sprint. It will be rolled out in May. So this is not really about risk analysis, but about assessing the status of a test run. We call it the fireworks chart because, it is like a little firework in the sky. And this is like an alternative form of status reporting, moving again away from text and tables toward a more organic representation. And in the center, we see a circle that displays the execution rate. And moving outward, we see the breakdown of test suites and test cases. So it is similar to a tree, but more compact. It fits into just one screen. And each node, again, is a test suite. the first point. Then we have folders, and each leaf or ending dot is a test case. And having this, we can see with the different colors how is the status of the project. And you can quickly identify the red parts. That means the test cases have failed or they are blocked. The blue parts in this screen here would be the past test cases, and everything that is gray is not yet executed. And you could use this for like status meetings or customer updates or something. Good. Well, now we are almost at the end. Let's summarize today's session. So we talked about risk-based testing, and we provided insights into how MGM developed a multi-layered risk assessment approach. This method is scientifically grounded, and our goal was to optimize the test selection and the test execution process for more efficiency. This saves time, reduces effort, and saves money ultimately in the end. And our approach and process have been integrated to the Q12-TMT Test Management Tool. So it's now available to other companies as well. If you would like to try out or evaluate Q12 yourself, then feel free to do so. You can register at q12-tmt.com. We just require minimal data, name and email address, so we can log in and display your name. It's free to use for a certain amount of time, so you can evaluate. And also you can find pre-configured data, so you can start right away, but you can also extend the data to your needs and to modify the data set that is existing. That concludes today's webinar. So finally, an overview of upcoming webinars in this series. The next one will be, I think, for the US or North America. We called it this on 8th of May. And it will deal with how to move away from spreadsheets for test management to a professional tool, how you could enhance your test management. And we have also other webinars coming in June about radical economic approaches in test management. And if you would like to meet us in person, we are also attending several conferences in Vietnam and Germany and in France. Maybe in September, also in the US, in the Star West conference, but it's not yet sure. It's quite expensive, so a little discussion with the bosses.
Pushing to get you guys over here.
Yeah, that would be great. But anyway, that's it. Thank you very much. I will now hand back to Joe.